Alright, so this is my first homework assignment attempt where we're going to be doing some videos at home and you'll take some notes and then we'll discuss in class. To begin with, we're going to review the place value system. Place value, as you learned probably starting in kinder with the little bundle charts you did where you bundled tens and then you made 100, is based on 10. Each time you move this direction, you get larger by a group of 10, and each time you move this direction, you're dividing by a group of 10. The direction or the multiplication or division is done based on this decimal point. We're going to start by filling out the place value chart on the whole number side. Most of you probably already know this is the ones, the tens, and the hundreds. These are your units. That's what this period is called. Then we move into the next period, which is the thousands. You have the 1,000s, but we call it just the thousands, the 10,000s, and the 100,000s. This period, of course, is the thousands. It's kind of like having a last name. These are separated, these periods, by a comma. As we move into the next period, separated by a comma, we have the millions period. And we have, of course, the millions, or the 1 millions, the 10 millions, and the 100 millions. Followed by another comma, and we move into the billions period with the billions, the 10 billions, and the 100 billions. Now, when I think about place value on the whole number side, I think about houses. The units would be a small house. Ones, tens, and hundreds are small values. Then we have the thousands, who are a little bit bigger. So we're going to notate that by making the top of their house just a little bit bigger. The millions family is even bigger than the thousands, and the billions is obviously the biggest family we have to the left of the decimal point. In all of our families, we have hundreds, tens, ones, hundreds, tens, ones, hundreds, tens, ones, hundreds, tens, ones. Where it gets tricky is on the other side of the decimal point. There are no oneths because a oneth would be something over 1. Because our place values over here, the denominator is actually the name of the place. So here we're really talking about taking 10 of these to make one whole, which would be tenths. Here we need 10 groups of 10, which is 100, to make a whole. So we call these the hundredths. Thousandths, meaning it takes 1,000 to make a whole, making this the thousandths place. Then we keep moving on, and the pattern kind of stays the same. We're going to have the 10,000ths, and of course, it takes 10,000 to make a whole. We have the 100,000ths, which takes 100,000 to make a whole. Then we have the millionths. Can you guess how many it takes to make a whole? 1 million. We are talking something very, very, very small. After the millionths, we have the 10 millionths, which takes 10 million to make a whole. And then rounding out our decimals that we're going to work with are the 100 millionths, which it takes, you guessed it, 100 million to make a whole. Now that we have our place value chart, let's talk about how you name numbers that include decimals. Oftentimes, we need to know the name of a number to help us figure out what fraction value goes with it, because decimals and fractions are related. They're all parts of a whole. So we're going to start off with something small when we try this on together. And we're going to start with this number here. Most people take the shortcut and say 2.145. That doesn't really help you, because if I ask you to change this to a fraction, you may not know how. To help you name this number, you're going to say the whole number value, which in this case is 2. You'll say this lovely decimal point by saying the word and then you will read the number and obviously use the last name or the place in the decimal places where it lands. So if I were to change this to a fraction, or want to change this to a fraction, I would need to know what place it ends in. In this case, we're ending in the thousandths place. So this is read 145 thousandths. And that's how we would write it. 145 thousandths. This is a way to help you also make the fraction, because now we know that the fraction would be 145 over 1,000. 2 and 145 thousandths. There's also a small shortcut or a trick that I can share with you that I learned from a student of mine many years ago. His name was Xavier, and you'll hear me refer to this as Xavier's method, named after the student. In a discussion we were having about decimals, he found a connection. He found that the number of places after the decimal point is equal to the number of zeros in your denominator. This can really help you when you get to a big number. So let's look at a large decimal place. And let's try using Xavier's method to help us. To do that, we're going to switch it to a fraction and use that also to help us figure out what and how to say and name this number. So the first thing I'm going to do is write a big one, because we have one whole. Then I know I'm going to have a fraction, and my numerator is going to be that number. My denominator is going to be, counting the number of places, 1 0 and 1 2 3 4 5 zeros to follow. Excuse me. I believe I said 1 0. I meant 1 1. You put a 1 and then you're going to add 5 zeros afterwards. So, using this method, we would have 1 and 12,352 hundred thousandths. And if we look and check our place value chart, you will notice that we have 5 places here, and if we count over 1, 2, 3, 4, 5, we end in the 100,000th place. It's a great trick, right? Help you all the time. So what I'd like you to do is to try this one on your own. You can try using Xavier's method to help you find the fraction, and then to be able to write it in word form. We'll go over this one in class. The next section on this review wants to round numbers. Most of you probably remember 5 or more, round up, 4 or less, round down. However, the trick is really finding where you're going to round to and using that to help you. So let's use the number we used right here. And let's round it to the tenths place. Okay, identifying the tenths place from my chart, I see that the number we're looking at is right here. I always underline the place I'm rounding to because it helps me to know which numbers to look at. I know I need to look at this 3 that's in the 10th place, and I also need to look at the number to the right of the 3, which is also a 3. 4 or less, and you're going to round down, just like your fingers close down over your hand. 5 or more, you have a thumbs up, so you're going to go up to the next digit. In this case, we have a 3, so that's going to round down, and our rounded number is going to be 2.3. Let's let you try this one on your own. And let's round this number to the thousandths place. Okay? I'd like you to try that, and we'll go over that one in class. Now we're going to talk about square numbers. You're going to be seeing a lot of square numbers. I want to show you something that will really help you to understand square numbers. This involves square tiles that you've probably seen and will be using a lot in class with. Okay? This is a square number right here. It's the number 1. Most of you probably already knew it was square. And basically, the way I like to think about it is it's a square number because if you built an array, the array out of color tiles would be a 1 by 1. So let's talk about 2. If we're building an array that's 2 by 2, you'll notice that the shape also makes a square. So 4, the number 4, 1, 2, 3, 4, is a square number. Why? Because the array makes only the shape of a square. Let's look at 3 by 3. Again, the shape makes a square number. So the number is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 9 is a perfect square. Why? Because its array is in fact a perfect square. You're going to hear the word square root used a lot. Basically, the square root is looking at a square number and figuring out what one side of the square is. If you can figure out one side, there in fact you know all the sides. It's kind of like finding the area of a square and using the area of a square to figure out a side. So if I told you the area of this square was 9 and I asked you what the length of one side is, you'd in essence be finding the square root. In this case, which is 3. I believe most of you have had some experience with square roots and perfect squares in 7th grade. So now I'd like you to take time to explain what a square number is using a picture and some words, and we'll discuss that in class in group for warm-up. Then I'd like you to fill in the chart for the rest of the perfect squares. I'll give you a hint. It's pretty easy if you can count. I'll see you in class, boys and girls. Have a great night.